Okay, real quick, conditional probability and independence. I'm just going to whip through this and just kind of give a brief overview. We're going to talk about two-way tables and calculating probabilities. Okay, so the probability of an event can change if we know that some other event has occurred. So we call this the probability of B given A. All right, this is a conditional probability. Notice in this formula, it's the intersection over the probability that of the given event. All right, and that's how we write the conditional probability. Now this is just an example of one, and this kind of goes through on how to determine if they are independent events. And we'll go through this a little bit more in depth, and I'll cover this formula a little bit later. All right, here's an example or just a question. Students at the University of New Hampshire received 10,000 course grades in a recent semester. The two-way table breaks down these grades by which school of the university taught the course. So you have 3 schools: liberal arts, engineering, physical science, and health and human services, and your grades are A, B, and lower than B. The schools are, so the University of New Hampshire course grade at random. Consider the 2 events. E is the grade comes from an EPS course, and L, the grade is lower than a B. So we want to find the probability of L given E. So it comes from EPS, so that would be this column right here. All right, so that's the given, that would be your denominator, okay? And then the probability that the grade is lower than B. All right, sorry, I take that back. You have to add up all of these, and that'll be your denominator. Okay, so it's the 368 plus 432 and 800, which goes here, and the probability that is lower than B, that's that intersection, so it would be 800, whatever that total is, okay, in that column. All right, so that was a brief explanation of that, and we'll go further in depth with our lesson.